Hello everyone, welcome to the series of C tutorials. In this presentation, we will be concentrating on bitwise operators. Bitwise manipulation is one of the important concept at system level programming, where most of the time we will be dealing with getting part of bits, setting parts of bit, and clearing parts of bits. There are 6 bitwise operators in C language, that is bitwise OR, AND, invert, XOR, left shift and right shift. We will practically see the working of these 6 operators. Let's define 2 unsigned character variables A and B with value 3 in decimal and 15 in decimal. This is equivalent to 3 in decimal. This is equivalent to 15 in decimal. Now we will perform all 6 operations, bitwise operations. This is OR, next bitwise AND operation, bitwise invert operation, we can invert only a single value. Bitwise XOR operator, bitwise right shift, we will right shift the value of A by 1 position. Next, bitwise left shift, we will left shift the value of B with 1 position. We will compile the program and we will see the output. A or B. If we OR the value of A and B, 1 or 1 is 1, 1 or 1 is 1, 0 or 1 is 1, 0 or 1 is 1, 0 or 0 is 0, and so on. So the value of A or B is 15, which is consistent with our understanding. Next, A and B. 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, and so on. So the value should be 3. Yes, it is consistent. Next is invert. Invert flips the value from 0 to 1 and 1 to 0. So the invert of A is -4. Next is A XOR B. 1 and 1 XOR 1 is 0, 1 XOR 1 is 0, 0 XOR 1 is 1, 0 XOR 1 is 1, and 0 XOR 0 is 0. So the value should be 12, yes, which is consistent with our operation. Next is A right shift 1. If we right shift the number A to 1 position towards right, this becomes 1. So the A right shift 1 is 1. And the same follows for left shift. Like I said before, bitwise manipulation are generally used in lower level programming such as device drivers and part of operating system programming, where we need to manipulate the register values. This is a simple program to find the size of integer using bitwise operations. Here we defined an unsigned integer and we initialized value negation of decimal 1, which replaces all zeros with 1. We don't know the size of integer yet. We will come to that in a moment. Next, we defined an integer variable. Here we are looping the length variable until the value of length becomes 0. And we are incrementing the count, that is, we are keeping track of the length of integer variable, and we are left shifting the value of length with one position on each iteration. Once the value becomes 0, we will come out of the loop and we will print the size of the integer. In this problem statement, we are supposed to set the 4th bit in a given number. Our task is to set this bit to 1. 0, 1, 2, 3, 4, 4th bit to 1. First we will take a given number as it is and keep it aside. Then we will take one more number and we will left shift 1 with the given position. In this case, we are taking 1 and we are left shifting till the 1 goes to 4th bit. Finally, we will perform bitwise OR operation to set a given bit. We can check this practically in our unsigned char a is equal to 0x double a, which is equivalent to 10101010. Hope I am right. Yes. We need to set the 4th bit. 0, 1, 2, 3, 4. This bit we need to make it as 1. So we will write a simple function. Here we will pass arguments unsigned int number and position. Return, let it be unsigned. Return number bitwise OR and shift 1, left shift 1 to a given position. Now we will print the output. Set number and position. 186, which is 10111010 in binary is equal to 186 in decimal. This is consistent to our problem statement. This is the next problem statement. Here we need to clear a given bit in a register. The given value is double A in hexadecimal. First we will take the given number as it is and keep it aside. Then we will left shift 1 to a given position. In this case, we are clearing the fifth bit, 0, 1, 2, 3, 4, 5, fifth bit. We need to clear this bit, make it as 0. So what we will do is take 1 and left shift to a given position and negate the whole value. So the fifth position becomes 0 and the rest becomes 1. Finally, we will perform AND operation to get the final result. This video is presented by Avari Technologies. Please to hit subscribe button to get more content. Thank you.